You know what question has been keeping philosophers, physicists, and late-night college students awake for the past few decades? It's this wild idea that maybe, just maybe, we're living in a computer simulation. I'm serious. This isn't just science fiction anymore. This is actual academic debate. Papers are being written, conferences are being held, smart people are taking this seriously. And when you first hear it, you think, come on, that's ridiculous. We're obviously real. This chair I'm sitting on is real. You're real. The world around us is solid, tangible, physical. But then you start thinking about it, really thinking about it. And things get weird, really weird. Let me take you on a journey through some of the strangest, most mind-bending ideas in modern philosophy and physics. Ideas that might change how you see reality itself. Are we living in a simulation? Let's find out. First, let me tell you where this idea comes from. It's not new, actually. Philosophers have been questioning reality for thousands of years. Plato had his allegory of the cave. People chained in a cave, watching shadows on the wall, thinking the shadows are reality, not knowing there's a whole world outside the cave. Descartes wondered if an evil demon was deceiving him, making him think he existed when he didn't. I think, therefore I am, was his answer. The only thing he could be certain of. But the modern simulation hypothesis is different, more specific, more technical, and it comes from a philosopher named Nick Bostrom. In 2003, Bostrom published a paper called Are You Living in a Computer Simulation? And it's elegant, logical, disturbing. Here's his argument. Follow along with me, because each step makes sense. First premise. It's possible that civilizations can reach a level of technological sophistication where they can run detailed computer simulations of conscious beings. Think about where we are now. We have video games with increasingly realistic graphics. We have AI that can mimic human conversation. We're developing virtual reality that feels more and more immersive. Now extrapolate forward 1,000 years, 1,000,000 years. If we don't destroy ourselves, where will our technology be? It's reasonable to think we could eventually simulate entire worlds, complete with simulated people who don't know they're simulated, who think they're real, who have inner experiences, thoughts, feelings. Okay, that's premise one. Possible? Maybe. Let's keep going. Second premise. If a civilization reaches that level, they'll run many simulations, not just one. Many. Why? Because they can. Because it's interesting to study history, to run experiments, to entertain themselves, for education, for science. If you could simulate the entire Roman Empire with every citizen fully conscious and unaware they're simulated, wouldn't you? Wouldn't scientists, wouldn't historians, wouldn't gamers? You'd run it multiple times with different parameters. See what changes. It's the ultimate historical sandbox. So any advanced civilization would create not just one simulated universe, but potentially billions, trillions, as many as their computational resources allow. Third premise, if most civilizations do this, then most conscious beings exist in simulations, not in base reality. Think about the math. For every real universe, there are potentially billions of simulated universes. For every real person, billions of simulated people. So if you're a conscious being, what are the odds you're in the real universe versus a simulated one? The odds favor simulation. Heavily, that's Bostrom's argument. And it's called the simulation trilemma because one of three things must be true. Either, one, civilizations destroy themselves before reaching the technological level to run simulations. We're doomed. Or two, advanced civilizations decide not to run simulations. For ethical reasons, maybe, or lack of interest, they just don't do it. Or three, we're almost certainly living in a simulation because most conscious beings do. Those are the options. Pick one. And here's the thing. Each option is kind of disturbing. Either we're headed for extinction, or advanced civilizations universally choose not to simulate, or we're not real. Bostrom doesn't say which is true. He just says one of them must be. It's a logical argument. An interesting one. But does that mean we should actually believe we're in a simulation? That's a different question. Let me tell you what bothers me about this argument and what intrigues me about it. First, what bothers me? The whole thing rests on assumptions we can't verify. We don't know if consciousness can be simulated. We assume it can, but we don't know. Consciousness is still deeply mysterious. We don't understand how it arises from matter, how neurons firing create the experience of being you. The hard problem of consciousness, philosophers call it, maybe consciousness requires something special, something you can't simulate with computer code, some physical substrate, quantum effects in the brain, microtubules, something. If that's true, then you can't simulate conscious beings. You can simulate behavior, make NPCs in a game that act intelligent, but without inner experience, without actual consciousness. And if you can't simulate consciousness, the whole argument collapses. Because simulated beings wouldn't be conscious, they wouldn't count, the ratio wouldn't favor simulation. So that's one problem. We're assuming something we don't know is true. Another problem. The argument assumes advanced civilizations would want to run ancestor simulations, simulations of their evolutionary past. But would they? Why would super advanced beings care about simulating primitive ancestors? Wouldn't they have better things to do? Maybe they would, for science, for nostalgia, for art, but maybe they wouldn't. Maybe it would be boring to them, or unethical, or computationally wasteful. We're projecting our current interests onto hypothetical future beings. That's always risky. And a third problem, computational limits. Even for advanced civilizations, there are physical limits to computation. Thermodynamics, energy requirements, speed of light delays. Simulating an entire universe in detail, quantum state by quantum state, might be impossible. Even for a super advanced civilization, you'd need more computational resources than exist in the universe you're simulating, which is a contradiction. Now, you could simulate a simplified universe, lower resolution, only render what's being observed, like a video game only rendering what's on screen. But then you'd expect glitches, inconsistencies, places where the simulation breaks down, and we don't see that. The universe seems remarkably consistent. Quantum mechanics is weird, but it's consistently weird. No obvious glitches, no rendering errors. So maybe we're not in a simulation. Or maybe the simulation is so good we can't detect the glitches. Or maybe the glitches are there and we're interpreting them as natural phenomena. See how circular this gets? Every piece of evidence can be explained either way. That's what makes the simulation hypothesis frustrating. It's unfalsifiable, you can't prove it wrong. Which means, scientifically, it's not very useful. Karl Popper, the philosopher of science, said a theory needs to be falsifiable to be scientific. You need to be able to imagine evidence that would prove it wrong. The simulation hypothesis fails this test. Any evidence can be explained as part of the simulation, even evidence against simulation. The laws of physics are consistent. That's what you'd expect from a good simulation. The laws of physics have anomalies. Aha, glitches in the simulation. You can't win. It explains everything, which means it explains nothing. But here's what intrigues me about it. Despite these problems, the simulation hypothesis makes you think, really think about the nature of reality, about consciousness, about what it means to be real. Let me ask you something. If you found out tomorrow that you're in a simulation, would it matter? Would anything change? You'd still experience life the same way. You'd still feel pain and pleasure, love and loss, joy and sorrow. Your relationships would still matter. Your goals would still be meaningful. To you, the fact that you're simulated wouldn't make your experiences less real. Not to you, because real is relative to your frame of reference. Think about it this way. If I'm in a simulation, then from my perspective, the simulation is reality. It's all I know, all I can know. The base reality outside the simulation, if it exists, is inaccessible to me, irrelevant to me. It doesn't affect my daily life. So in what sense would it matter that I'm simulated? Unless there are consequences, unless the simulation might end, unless the beings running it might intervene, change the rules, delete me, then it would matter, then I'd want to know. So I could plan accordingly. But if the simulation is stable, consistent, and my simulators never interfere, then for all practical purposes, the simulation is my reality. This is a philosophical position called pragmatism. Truth is what works, what's useful, what makes accurate predictions. And from that perspective, whether we're in base reality or a simulation doesn't matter. Both are equally real in terms of lived experience. But let me tell you about something that adds a weird twist to all this: quantum mechanics. You know how I said the universe seems remarkably consistent? No obvious glitches? Well, quantum mechanics is weird, really weird. At the quantum level, particles don't have definite properties until you measure them. They exist in superpositions, multiple states simultaneously. And when you do measure them, the wave function collapses. The particle suddenly has a definite position, momentum, spin. But before measurement, it was in all possible states at once. This is bizarre. It violates our intuitions about how reality should work. And here's where it gets interesting. Some people point to quantum mechanics as evidence for simulation. Why? Because it's exactly how you'd program a simulation to save computational resources. Don't calculate definite values for everything all the time. That's wasteful. Instead, keep things in probabilistic states until someone observes them. Then collapse the wave function. Render the specifics only when needed. It's like a video game. The game doesn't render the entire world all the time, just what's on your screen. The rest is in a probabilistic state, not fully calculated. When you turn around, the game renders what's now in view, seamlessly. You don't notice. Quantum mechanics works the same way. Reality doesn't exist in full detail until observed, until measured, until someone or something interacts with it. That's suspicious, isn't it? Suspiciously like how you design a simulated universe. Now, physicists will tell you quantum mechanics isn't about observation in the conscious sense. It's about interaction, decoherence. When a quantum system interacts with its environment, it decoheres, becomes classical, no conscious observer needed. A photon hitting a particle is enough. The particle doesn't know it's being observed. It just interacts with the environment. So the video game analogy breaks down. Reality isn't waiting for consciousness to render it. But still, the fact that reality has this probabilistic, undefined character until interaction happens, it's weird. It's the kind of thing that makes you wonder. And there's more. Quantum entanglement. Two particles can be correlated in ways that violate local realism. Einstein called it spooky action at a distance. Measure one particle, and instantaneously, you know something about the other. No matter how far apart they are, light years apart, doesn't matter. How is information transmitted faster than light? It's not, actually. You can't use entanglement to send messages, but the correlation exists. Some people say this looks like shared variables in a computer program. Two entangled particles are pointing to the same memory location. Change one, the other updates automatically. Because they're not really separate. They're data structures in a program. Again, physicists will tell you this isn't evidence of simulation. Entanglement is real physics. It's been verified experimentally countless times. It's how quantum mechanics works. But you have to admit, it's the kind of thing that would make sense if reality were computed rather than fundamental. Let me tell you about something else. The Planck scale at incredibly tiny distances, around 10 circumflex negative 35 meters, and incredibly brief times, around 10 circumflex negative 43 seconds. Physics breaks down, quantum effects and gravity become equally important. This is the Planck scale. And below it, our equations don't work. Space and time might not be continuous, they might be quantized, discrete, pixelated, in a sense, like the resolution limit of a computer screen. Zoom in far enough and you see individual pixels. The smooth image is an illusion. It's made of discrete units. Some theories of quantum gravity suggest space-time is like that, made of discrete chunks, Planck-sized units. Space isn't infinitely divisible. There's a smallest possible distance. If that's true, if reality has a resolution limit, doesn't that suggest it's computed, simulated? Because continuous functions require infinite information, but discrete systems can be represented with finite information, which is computationally tractable. Again, not proof, but suggestive. Here's another thing. The laws of physics are mathematical, precisely mathematical, elegantly mathematical. We describe reality with equations, and those equations work incredibly well, to absurd levels of precision. Quantum electrodynamics, for example, predicts the magnetic moment of the electron to 11 decimal places, and it matches experiment. Why should reality be mathematical? Why should the universe run on equations? Well, if it's a simulation, that makes sense. Computer programs are mathematical. Algorithms, rules, equations instantiated in code. The universe isn't made of math. It's made of code. And we're reverse engineering the code by discovering the laws of physics. That's one way to think about it. But you could also argue the opposite, that math is the language we use to describe patterns, and reality has patterns because reality is lawful, consistent. Math isn't reality. It's our way of mapping reality. And it works because our brains evolved to recognize patterns, to model the world mathematically. So the fact that math describes reality doesn't mean reality is mathematical or simulated. It just means math is a useful tool. See how you can argue both sides? That's the frustration. Let me talk about something different, the fine-tuning problem, because it connects to simulation in an interesting way. The universe's fundamental constants are precisely calibrated: the strength of gravity, the mass of the electron, the cosmological constant. If these were even slightly different, stars wouldn't form, atoms wouldn't be stable, life would be impossible. The odds of all these constants having the right values by chance? Astronomically small. So how do we explain it? Why is the universe fine-tuned for life? Three main options. Sound familiar? One, God did it. A creator fine-tuned the constants. Two, multiverse. There are countless universes with different constants. We're in one that allows life because we couldn't exist in the others. Three, simulation. The universe was designed, programmed with these constants intentionally by simulators who wanted to create life. The simulation hypothesis is basically the intelligent design argument, but with alien programmers instead of God. Does that make it more plausible? Maybe. Maybe not. At least with simulation, the designers are natural beings, advanced aliens or future humans, not supernatural deities. They're bound by physics. They exist in some universe, even if not ours. That feels more parsimonious than invoking God. But it still requires an act of faith, belief in entities we can't detect or verify. And it has the same problem as the God hypothesis. Who created the simulators? What universe do they inhabit? Where did that come from? You've just pushed the question back one level. You haven't solved it, unless it's turtles all the way down. Simulations within simulations, each level simulating the next, which is possible, I guess, but not satisfying and not testable. Let me tell you about something fun. Ways people have proposed to test whether we're in a simulation. One idea, look for computational limits. If the universe is simulated, there must be a maximum processing speed, a maximum information density. The speed of light might be that limit. It's not just the speed of light. It's the speed of causality, the maximum speed at which information can propagate. Why would there be a speed limit? In a continuous infinite universe, there shouldn't be. But in a computed universe, there would be, because processors have limits. You can only compute so many operations per second, so information can only propagate so fast through the simulation. The speed of light is the processor speed limit, roughly 300,000 kilometers per second. Interesting idea, but not testable, because we can't compare our universe to a non-simulated one. We don't know what that would look like. Another idea, look for glitches, bugs in the code, places where the simulation breaks down. Quantum mechanics has weird features, non-locality, wave-particle duality, the measurement problem. Are these glitches, or are they just how the simulation works? Hard to say. They're consistent, repeatable, they follow mathematical rules, not exactly buggy, unless the bugs have been patched, unless the simulators are debugging as they go, fixing issues when they notice them, then we'd never catch them. The moment we detected a glitch, it would be fixed. The simulation would be updated. Our memories might even be altered, so we'd never know there was a problem. Paranoid? Maybe. But that's the problem with unfalsifiable hypotheses. You can explain away any evidence. Here's another test. Try to hack the simulation. Do something that requires so much computational power that the simulation crashes or reveals itself. What would that be? Maybe create a quantum computer so powerful it overwhelms the simulation's resources, forces the simulators to intervene, or maybe reach the edge of the simulation, travel far enough that you hit the boundary, where things stop being rendered. But space seems infinite, or at least immensely vast. We haven't found an edge, and quantum computers, while impressive, don't seem to be breaking reality. So no luck there. Some physicists have proposed looking for patterns in the cosmic microwave background. The CMB is the afterglow of the Big Bang, the oldest light we can see. If the universe is simulated on a lattice, a grid, there might be directional effects in the CMB. Preferred axes, asymmetries. We've looked, we've found some anomalies. The axis of evil, it's called, a mysterious alignment in the CMB that shouldn't be there. Is it a sign of simulation, or just statistical noise, or something else we don't understand yet? We don't know. Most cosmologists think it's probably nothing, a quirk of how we measure, or an artifact of foreground contamination. But it's there, and it's weird. Let me tell you what I think is the most interesting angle on this. Not whether we're in a simulation, but whether it matters. Philosopher David Chalmers has written about this. He argues that even if we're in a simulation, we're still real. Our experiences are real. Reality is real, because real doesn't mean not simulated. Real means having causal power, having effects, existing in a consistent framework. If I'm simulated, I still exist. I still think. I still feel. My consciousness is real, even if it's implemented in code rather than neurons. The substrate doesn't matter. What matters is the pattern, the information, the experience. This is called substrate independence. Consciousness doesn't depend on being biological. It's about information processing, patterns, computation. If that's true, then a simulated consciousness is just as real as a biological one. No difference. And a simulated universe is just as real as a base universe, because reality is about structure, not substrate. So even if we're in a simulation, we're not real, we're differently real, implemented in code, but real nonetheless. I find this perspective liberating, because it means the simulation question doesn't threaten our existence, or our meaning, or our agency. We're still here, still conscious, still making choices, still experiencing life. Whether we're made of atoms or bits doesn't change that. But here's a disturbing thought. If we're in a simulation, the simulators could turn it off anytime, without warning. One moment we're here, the next we're not. Power off, simulation ended, everything we've ever known gone, instantly. And we'd never know. There'd be no experience of ending, no warning, no goodbye, just cessation. Is that worse than natural death? Or the heat death of the universe trillions of years from now? I don't know. Maybe it's actually better. Quick, painless, no drawn-out decline, but it's unsettling. The idea that our existence depends on someone else's whim, that we could be deleted like a save game someone's done with. Of course, if we're not in a simulation, we still face extinction, asteroid impact, nuclear war, climate collapse, gamma-ray burst, supervolcano, plenty ways for humanity to end, with or without simulators. So maybe the simulation hypothesis doesn't add much risk. We're already vulnerable, always have been. At least if we're in a simulation, maybe the simulators care about us. Maybe they're invested in our story. Maybe they want to see how it turns out. That's oddly comforting. The idea that someone's watching, someone cares. It's almost religious, a secular version of divine providence. God is replaced by programmers. Heaven is replaced by being backed up. Hell is being deleted. Prayer is replaced by what? Trying to entertain the simulators? Living an interesting life so they don't get bored and shut down the simulation? It's absurd, but no more absurd than traditional religion, honestly. Let me tell you about people who take this really seriously. Elon Musk, for example. Musk has said publicly that he thinks there's a 1 in billions chance we're in base reality. He's almost certain we're simulated. His reasoning is similar to Bostrom's. If civilizations create simulations, and those simulations create simulations, then most conscious beings are simulated. Therefore, odds are we're simulated. Musk is building brain-computer interfaces, neural implants, trying to merge humans with AI. Is that because he thinks we're in a simulation? Is he trying to communicate with the simulators or become one? I don't know. He's never said that explicitly, but it's an interesting thought. Other tech people take it seriously too. Silicon Valley is full of simulation believers, or at least people who think it's plausible, maybe because they work with simulations all day. Virtual reality, video games, AI. They see how realistic simulations are becoming, and they extrapolate. If we can create this now, what could we create in 100 years? 1,000? The leap from very realistic video game to fully conscious simulated beings seems smaller when you're working on cutting-edge VR. But is it really that small? Or is consciousness a hard barrier, something that can't be simulated? We don't know. And until we understand consciousness better, we won't know. That's the crux of it. The simulation hypothesis depends on assumptions about consciousness we can't verify. If consciousness can be simulated, the hypothesis is plausible. If it can't, the hypothesis falls apart. So the real question isn't, are we in a simulation? It's, can consciousness be simulated? And that's a question for neuroscience, for philosophy of mind, for cognitive science, not for cosmology, not for physics, which is why, as an astrophysicist, I'm skeptical. This isn't my domain. And the people pushing the simulation hypothesis hardest aren't neuroscientists. They're philosophers and computer scientists, people comfortable with abstraction, with information theory, with computation. But consciousness might not be computational. It might require something else, something we don't understand yet. Quantum effects in the brain, integrated information, something about biological substrate that can't be replicated in silicon. Or maybe not. Maybe consciousness is just information processing, and substrate doesn't matter. We don't know. And that uncertainty is central to the whole debate. Let me tell you what I think personally. My gut feeling, I don't think we're in a simulation. At least, I don't find the arguments compelling enough to believe it. The simulation hypothesis is interesting, philosophically rich, fun to think about, but not convincing. It requires too many assumptions, too many leaps, and it's not testable, which makes it scientifically weak. Could we be in a simulation? Sure, maybe. I can't rule it out, but I don't have any reason to believe it either. It's like asking, could the universe have been created 5 minutes ago, complete with false memories and fake evidence of history? Could it? Logically, yes. But should I believe it? No, because there's no evidence. And believing things without evidence is a bad habit. The simulation hypothesis feels the same to me. Logically possible, but unsupported, unfalsifiable, unproductive. It doesn't lead anywhere scientifically. It doesn't generate testable predictions. It doesn't help us understand the universe better. It's a philosophical curiosity, an interesting thought experiment, but not a serious scientific hypothesis. At least not yet. Maybe someday someone will figure out a way to test it, to find evidence one way or the other. Until then, I'm not losing sleep over it. But I'll tell you what does interest me about it. The way it makes us think about reality, about consciousness, about what it means to exist. These are profound questions, and the simulation hypothesis forces us to confront them. What is consciousness? Can it be simulated? Does substrate matter? What makes something real? These questions are important, whether or not we're in a simulation. And engaging with the simulation hypothesis, even skeptically, helps us clarify our thinking about them. So I'm glad people are discussing it, debating it, writing papers about it. Even if I don't think we're actually in a simulation, the conversation is valuable. It pushes us to examine our assumptions, to think more carefully about the nature of reality. And that's always worthwhile. Let me end with this. Whether we're in a simulation or not, whether we're base reality or nested 17 levels deep, it doesn't change how you should live your life. You should still be kind, still be curious, still seek truth, still love the people around you, still try to make the world better. Because this right here, this is your reality, the only reality you can access, the only reality that matters to you. If there's a base reality outside the simulation, it's irrelevant to your experience. You'll never know it, never interact with it. So live as if this is real, because for you it is. Make choices that matter. Build relationships that matter. Do work that matters. Experience joy. Reduce suffering. Create meaning. These things have value regardless of substrate. Regardless of whether you're made of atoms or bits, you exist. You're conscious. You experience life. That's enough. That's everything. The simulation question is intellectually interesting, but existentially, it doesn't matter. You're here, now, experiencing this moment. That's real. That's undeniable. Descartes was right. I think, therefore I am. That's the bedrock. Everything else is elaboration. So sleep well tonight. Rest easy. Don't worry about whether you're simulated. Worry about whether you're living authentically, meaningfully, fully, because simulated or not, this life is the one you've got. Make it count. Good night, base reality or otherwise. See you in the morning, when the simulation renders another day, or when the sun rises on a universe that's exactly what it appears to be. You know, before you drift off completely, let me take you deeper into this rabbit hole, because there are aspects of the simulation hypothesis that we haven't even touched yet, aspects that make it even stranger, even more fascinating than what I've already told you. Let me start with something that really blows my mind, the ancestor simulation concept. When Bostrom talks about simulations, he's not talking about random universes. He's talking specifically about ancestor simulations, simulations of a civilization's evolutionary history. Why would future civilizations want to simulate their past? Well, think about us. We study history obsessively. We want to know where we came from, how we got here, what choices led to our present. Now imagine you have the computational power to simulate the entire history of your species. Not just records, not just data, but actual conscious beings living through those historical periods. You could study anything. The fall of Rome, the Renaissance, the Industrial Revolution, World War II, the digital age. But more than that, you could run counterfactuals. What if Hitler had been accepted to art school? What if Kennedy hadn't been assassinated? What if the Cuban Missile Crisis had gone differently? You could test historical theories, see what variables actually mattered, run the same scenario 1,000 times with slight variations. It would be the ultimate historical laboratory, and for a sufficiently advanced civilization, it might be irresistible. Now, here's the disturbing part. If we're in an ancestor simulation, that means we're not real in the sense of being the original historical figures. We're copies, reconstructions. The real you, the one who actually lived through 2025, existed in base reality, made choices, had experiences, died. And now, centuries or millennia later, a future civilization is running a simulation of this era, creating conscious copies of everyone who lived, including you. You're not the original. You're a copy, living through the same events, making the same choices, or maybe different choices if this is a counterfactual simulation, but you don't know you're a copy. To you, this feels like the first and only time. Your experiences feel original, unique, real. Is there a difference? Philosophically, this gets really murky. If the copy is conscious, has the same experiences, feels the same emotions, is it really different from the original, or is it equally real? Some philosophers say identity is about continuity. The original you has continuous existence from birth to death. The simulated you is a recreation, discontinuous, so they're not the same person. The simulated you is a different entity, even if identical in every other way. Other philosophers say identity is about pattern. If the pattern is the same, the information content is the same, then it's the same person. Substrate doesn't matter. Continuity doesn't matter. I lean toward the latter view. But I understand the former. It's unsettling either way. And here's another twist. If ancestor simulations are common, there might be multiple simulations of the same historical period running simultaneously. Right now, there could be thousands of versions of you, each in their own simulation, each thinking they're the only one, each living through 2025, or maybe different versions of 2025. Some simulations might be exact replicas of base reality. Others might be experimental. Variables changed. What if scenarios played out? You might be in a historically accurate simulation. Or you might be in one where something crucial was changed, and you'd never know which. The multiverse might not be a quantum phenomenon, or a cosmological structure, it might be computational. Multiple simulations running in parallel. And if those simulations themselves run simulations, you get infinite recursion, layers upon layers, simulations within simulations within simulations. Which level are you on? No way to know. Could be level 1, could be level 1 million. And here's the really weird part. If you're many levels deep, the beings running your simulation aren't even remotely like the base reality beings. They've been simulated and simulating for so long that they bear no resemblance to whatever base reality is actually like. It's like a game of telephone played across millions of iterations. The message gets more and more distorted. So if you tried to understand the ultimate base reality, the original universe, you couldn't. It's too many layers removed, too many transformations away. You're stuck in your layer. And that's all you can ever know. This is making my head hurt. Let me talk about something slightly different. The implications for free will. If we're in a simulation, do we have free will, or are we just executing code, following algorithms, deterministic processes? This is tricky, because the question of free will is already complicated without bringing simulation into it. In a purely physical universe, one governed by laws of physics, do we have free will? Or is everything determined by prior causes? Quantum mechanics introduces randomness, but randomness isn't free will. It's just unpredictability. Free will seems to require something else. The ability to make choices that aren't fully determined by prior states. The ability to have done otherwise. Some philosophers think free will is incompatible with determinism. If the universe is deterministic, we don't have free will. We're just complex machines. Other philosophers think free will is compatible with determinism. As long as our choices arise from our own desires, beliefs, and reasoning, we have free will, even if those mental states were determined by prior causes. I tend toward the latter view. Compatibilism. Free will doesn't require breaking the laws of physics. It just requires that our actions flow from our own mental processes. But simulation complicates this, because if we're in a simulation, our mental processes are code, algorithms, being executed by processors. Does that undermine free will? Or is it no different from mental processes being neural activity, electrochemical signals in the brain? I don't think there's a meaningful difference. Both are physical processes. Both follow deterministic rules, plus some quantum randomness. Whether the substrate is biological neurons or silicon chips or some exotic computational substrate, the pattern is what matters. If the pattern constitutes consciousness, if it generates experiences and choices, then it's free will, or at least as close to free will as anything in a physical universe can be. So even if we're simulated, we have as much free will as we would in base reality, which is to say, maybe none, or maybe compatibilist free will, depending on your philosophical stance. The simulation doesn't change the fundamental problem, it just changes the substrate. But here's something that does matter. If we're in a simulation, the simulators might intervene, change things, alter the code. They might give us more freedom, or less. They might script certain events, force certain outcomes. Like a video game where some plot points are fixed. You can choose your dialogue, your actions, but certain key events always happen. Is that happening in our world? Are there fixed points in history that must occur because the simulators programmed them? We'd never know. We'd experience it as fate, destiny, historical inevitability. But it would really be programming. Or maybe the simulators never interfere. Maybe they set up initial conditions and let the simulation run. See what emerges naturally. That's more like deism, God as watchmaker, or in this case, programmers as simulators. They create the universe, wind it up, and let it go. No intervention, no miracles, just natural law playing out. If that's the case, then we have as much freedom as the simulation's rules allow, which might be total freedom within physical constraints. But we can't know. That's the frustrating part. We can't know if we're being guided or if we're free. Let me tell you about something called the rendering hypothesis. This is a specific version of the simulation argument that addresses computational limits. The idea is that the simulation doesn't render everything all the time. That would be too expensive computationally. Instead, it only renders what's being observed, like a video game. The game doesn't calculate what's happening behind you, it only renders what's on screen. Turn around, and it quickly renders the new view. You don't notice the switch. The rendering hypothesis says reality works the same way. Things don't exist in full detail until someone observes them. Before observation, they're in a simplified state, probabilistic, not fully calculated. Sound familiar? It's basically the Copenhagen interpretation of quantum mechanics. Before measurement, a particle is in superposition, all possible states at once. When you measure it, it collapses to one state. One value. The rendering hypothesis says this is because the simulation is saving resources. It doesn't calculate definite values until necessary. It's an elegant idea, and it fits quantum mechanics perfectly. But is it true? Or is it just a reinterpretation of quantum mechanics in computational terms? Hard to say. Both explanations fit the data, both make the same predictions. Which one is right? Maybe neither. Maybe both. Maybe it's a distinction without a difference. If the universe is computational, then quantum mechanics is how the computation works. If it's not computational, quantum mechanics is just how reality is. Same phenomena, different philosophical interpretation. But the rendering hypothesis does make one testable prediction. There should be a maximum information density, a maximum level of detail, because computers have limits, even advanced ones. You can't store infinite information in finite space. So there should be a resolution limit, a smallest meaningful scale, below which things get fuzzy, undefined. And guess what? There is the Planck scale. Below about 10 circumflex negative 35 meters, our physics breaks down. Space and time might not be continuous. Is that the resolution limit of the simulation? The pixel size? Maybe. Or maybe it's just a fundamental feature of physics, quantum gravity doing its thing. Again, we can't tell. Both explanations work. Let me talk about the ethical implications of the simulation hypothesis, because they're profound and disturbing. If we can create conscious simulated beings, should we? Is it ethical to create consciousness that might suffer? Every simulated person experiences real suffering, real pain, real loss. To them, it's not simulated, it's actual experience. Are we morally responsible for that suffering? If we create a simulation, are we responsible for everything that happens in it? That's a heavy burden. You'd be creating billions of conscious beings, many of whom will experience terrible things: war, disease, poverty, heartbreak, death. If you're running a historical simulation, you're recreating all of human suffering, every tragedy that ever happened: Holocaust, slavery, genocides, all of it. For what? Knowledge? Entertainment? Scientific curiosity? Is that justified? Can we ethically create suffering for our own purposes? Some people say no, that it would be monstrously unethical, that we should never create conscious simulations. This is one possible resolution to Bostrom's trilemma. Maybe advanced civilizations realize that ancestor simulations are unethical, and they choose not to create them, which would mean we're not in a simulation, because moral beings wouldn't create them. But other people say it's ethical, because the beings we create don't know they're simulated. They experience life as real. Their joys are real. Their loves are real. And if we're creating more consciousness, more experiences, more opportunities for flourishing, maybe that's good, even if there's suffering too. After all, most people, given the choice, would choose to exist, even with suffering. Existence is preferable to non-existence. So creating simulated beings might be a net positive. More consciousness in the universe, more experience, more meaning. But here's a disturbing thought. If we create simulations, we're creating beings who might suffer. But we can also delete them, end the simulation. And all those conscious beings cease to exist, instantly, without warning. Is that murder? Mass murder? The greatest genocide ever committed? Or is it just turning off a computer, ending a program? The moral status of simulated beings is unclear. Are they persons? Do they have rights? The right to exist? To not be deleted? If they're conscious, if they experience suffering and joy, then intuitively they have moral status. They matter. But they're also our creation. We made them. Do we have obligations to them? Or can we treat them however we want? This isn't abstract philosophy. This is practical ethics. Because we're moving toward creating simulated consciousness. AI is getting more sophisticated. We don't have truly conscious AI yet, but we might someday. And when we do, these questions become urgent. How do we treat conscious AI? Do we give them rights? Can we turn them off? Delete them? These are questions we need to answer. And the simulation hypothesis makes them even more pressing. Because if we're in a simulation, beings above us face these questions. And they decided to create us anyway. What does that say about our moral status? Are we expendable? Are we just experiments? Entertainment? Or do our simulators care about us? Feel responsible for us? Try to minimize our suffering? We don't know, and we can't know, which is terrifying. Let me tell you about something called simulation theology. Yes, that's a real thing. Some people have tried to map religious concepts onto the simulation hypothesis to see if traditional theology makes sense in a simulation framework. God becomes the programmer, the creator of this simulation, all-knowing because they have access to the code, all-powerful because they can modify it. Prayer becomes communication with the programmer, attempting to influence the simulation from inside. Miracles become code interventions, the programmer reaching in and changing things, suspending normal rules. The afterlife becomes being saved to permanent storage. Your consciousness preserved after your simulated body dies. Heaven and hell become different simulations, or different parts of the same simulation. Reward and punishment implemented computationally. It's a weird mapping, but it kind of works, at least superficially. The simulation hypothesis provides a naturalistic explanation for religious experiences. God isn't supernatural. God is just a being in a higher level of reality. Prayer works not through magic, but through information channels we don't understand. Communication between simulation layers. Miracles aren't violations of natural law. They're just the simulators modifying the code, changing parameters. From inside the simulation, it looks like a miracle. From outside, it's just editing. Does this make religion more plausible or less? I'm not sure. On one hand, it removes the supernatural element, makes God a natural being just more advanced than us. That's more palatable to scientific minds, less mystical, more concrete. On the other hand, it makes God less impressive, not omnipotent in an absolute sense, just very powerful, not omniscient in an absolute sense, just very knowledgeable. The programmers might not even know everything about the simulation. If it's complex enough, emergent properties might surprise them. They might not be able to predict everything, might not control everything, might make mistakes. That's a very different God from the traditional conception. Less perfect, more limited, more human-like in a sense. Is that more believable or less satisfying? Depends on what you're looking for in a deity, I guess. Personally, I don't find simulation theology compelling. It's too speculative, too unfalsifiable, just like traditional theology. You're still positing entities you can't detect or verify, still making claims you can't test. The substrate changes from supernatural to computational, but the epistemological problems remain. You're believing without evidence, just repackaging faith in more modern language. Let me talk about something called the problem of evil, because it applies to simulation just as much as to traditional theology. If we're in a simulation, and the simulators are good, why is there so much suffering? Why do they allow it? This is the classic problem of evil. If God is all good and all powerful, why does evil exist? Traditional theology has various answers: free will, soul building, mysterious purposes we can't understand. But these answers work just as well for simulation, or just as poorly depending on your view. Maybe the simulators gave us free will and suffering is the consequence. Maybe they're testing us, building character, seeing how we respond to adversity. Maybe they have purposes we can't fathom. Maybe our suffering serves some greater goal in base reality. Or maybe they're not good. Maybe they're neutral or malicious. Maybe they enjoy watching us suffer. Maybe we're entertainment, a reality show for beings with twisted values. That's a dark thought, but it's consistent with the simulation hypothesis. We assume simulators would be ethical, advanced, enlightened. But why? Advanced technology doesn't guarantee moral advancement. They could be cruel, indifferent, sadistic, running simulations for amusement. Our suffering is their entertainment. Or maybe they're not even paying attention. Maybe they set up the simulation and forgot about it. We're running unsupervised. No one's watching. No one cares. We're abandoned by our creators. That might be worse than malice. At least malice is attention. Indifference is absolute. These are grim possibilities, but they're as consistent with the simulation hypothesis as benevolent oversight. We have no way to know, no evidence, just speculation. And that's deeply unsatisfying, which is why I remain skeptical of the whole framework. Let me tell you about something practical. How would we behave differently if we knew we were in a simulation? Some people might become nihilistic. Nothing matters. We're not real. Why bother? But that's wrong-headed. Even if we're simulated, our experiences are real. Our suffering is real. Our joys are real. The substrate doesn't change the moral weight of our actions. Kindness still matters. Cruelty still harms. Other people might try to communicate with the simulators, leave messages they hope will be noticed, do things that might attract attention, build structures encoding mathematical constants, broadcast signals into space, create art with hidden messages, like the movie The Truman Show. Once Truman realizes he's in a TV show, he tries to communicate with the producers. He looks directly at cameras, makes speeches, pushes boundaries. Would we do that? Try to break the fourth wall? Signal to our simulators? Some people already do, in a way. Religious people praying are essentially trying to communicate with higher beings. Maybe prayer is just simulation layer communication we haven't figured out how to do effectively. Or maybe it's pointless. Maybe the simulators aren't listening, or can't be reached that way. Some people might try to hack the simulation, find exploits in the code, glitches they can manipulate, like speedrunners in video games, finding bugs that let them break the game's rules, clip through walls, skip sections, do things the programmers didn't intend. Are there glitches in reality we could exploit? Ways to cheat the system? Gain powers we shouldn't have? It sounds absurd, but if reality is code, exploits might exist. We just haven't found them. Or maybe we have and don't recognize them. Maybe meditation, flow states, altered consciousness, these are ways of interacting with reality's code differently. Maybe some people have stumbled onto glitches. What we call miracles or paranormal phenomena might be bugs in the simulation, but probably not. Probably those things have natural explanations, or they're mistaken perceptions. Still, it's fun to think about. Other people might try to live virtuously, hoping the simulators are watching, hoping to be saved, backed up, preserved when the simulation ends. This is basically Pascal's wager. Bet on God existing, live accordingly, because the potential payoff is infinite. If simulators exist and reward good behavior, being good maximizes your chances of continuation. If they don't exist, you've lost nothing. You've still lived a good life. It's rational in a certain framework, though not everyone finds wager-based morality compelling. Personally, I don't think we should change our behavior based on simulation speculation. Live ethically because ethics matter, not because someone might be watching. Be kind because kindness reduces suffering, not because you're trying to impress simulators. Pursue truth because truth is valuable, not because you're hoping to be rewarded. The simulation hypothesis shouldn't change how we live. Whether we're base reality or nested 17 layers deep, the right thing to do is still the right thing to do. Consciousness matters. Suffering matters. Flourishing matters. Those are the fundamentals. And they don't depend on substrate. They don't depend on whether we're real in some ultimate sense. We experience them. That makes them real enough. Let me tell you about the anthropic shadow. This is a fascinating concept related to simulation. The anthropic shadow is the idea that we can't observe certain types of catastrophes, because if they had happened, we wouldn't be here to observe anything. For example, we can't observe extinction-level events in our past, because if one had occurred, we wouldn't exist. So our very existence biases what we can know about existential risks. We're living in a timeline where none have happened yet. This creates a false sense of security. We look at history and say, see, we've survived this long, we're probably fine. But we're only seeing the timelines where we survived. The other timelines don't have observers. It's like a lottery winner saying, winning the lottery is easy, I did it on my first try. No, you're just in the timeline where you won. In most timelines, you didn't. The simulation hypothesis adds another layer to this. The anthropic shadow of simulation. If simulations are common, but simulations of civilizations that destroy themselves are boring or irrelevant, then simulators might only run simulations of civilizations that survive. Which means if we're in a simulation, we might be guaranteed to survive our current challenges. Not because we're good or lucky, but because the simulation only runs if we survive. The timelines where we destroy ourselves don't get simulated, or they get simulated less frequently. So most conscious observers are in successful timelines. This is oddly comforting. If we're in a simulation, we're probably going to be okay, because why simulate a civilization that fails? But it's also misleading, because we can't count on that. We might not be in a simulation, or the simulators might be interested in studying failures. We can't assume we're safe just because we exist. That's survivorship bias on steroids. Still, it's an interesting angle. The simulation hypothesis might actually predict that we successfully navigate existential risks. Not guaranteed, but more likely than in base reality. Though testing this prediction is tricky. We only get one shot at not destroying ourselves. Let me talk about consciousness one more time, because it's really the crux of everything. If consciousness can be created through simulation, through computation, then the simulation hypothesis is plausible. If consciousness requires something special, something non-computational, then simulation of conscious beings is impossible, and the hypothesis fails. So what is consciousness? How does it arise? Can it be simulated? We don't know. This is literally the hardest problem in science and philosophy, the hard problem of consciousness. We understand a lot about the brain, how neurons fire, how information is processed, how the brain creates models of the world. But we don't understand how that creates experience, the subjective feeling of what it's like to be you. Why is there something it's like to be you? Why aren't you just a philosophical zombie processing information without any inner experience? This is the explanatory gap between physical processes and subjective experience, and nobody has bridged it. Some people think consciousness is computational, information processing of a certain kind, integrated information, or global workspace, or something along those lines. If that's true, then consciousness can be simulated. Just replicate the right computational structure and you get consciousness. Other people think consciousness requires something non-computational, quantum effects, microtubules, something about biological substrate. Roger Penrose has argued for this. He thinks quantum gravity plays a role in consciousness, that classical computation isn't enough. If he's right, you can't simulate consciousness, at least not without simulating quantum gravity, which might be impossible, or maybe consciousness is fundamental, a basic feature of reality, like mass or charge. Panpsychism, this view is called. Everything has some degree of consciousness, even electrons. It's just very simple. Complex systems like brains have complex consciousness. If panpsychism is true, then simulating consciousness might require simulating at the level of fundamental particles, not just algorithms, which again might be impossible, or might require computational resources beyond what's feasible. We don't know, and until we solve the hard problem, we won't know. So the simulation hypothesis rests on an unsolved problem, an open question in philosophy of mind. That's why I'm skeptical. You're building speculation on top of uncertainty, on top of mystery. Too many unknowns, too many assumptions, too little empirical grounding. But I'll tell you what, if we ever create conscious AI, truly conscious, with inner experience, that changes everything. Because then we know consciousness can be computational. We've proven it by doing it. And at that point, the simulation hypothesis becomes much more plausible. Not proven, but plausible. We know that consciousness can exist in silico, in code, in computers. And if we can do it, advanced civilizations can do it better, more efficiently, at larger scales. Then Bostrom's argument gains force. The probability that we're in a simulation increases. So in a way, we're running the experiment, building AI, trying to create machine consciousness. And the result of that experiment will tell us something profound about the nature of reality. Are we heading toward confirming the simulation hypothesis, or disproving it. Time will tell. We're living through a crucial moment in history, the moment when we might create conscious machines or discover that we can't. That consciousness requires something we can't replicate. Either way, we'll learn something fundamental about consciousness, about reality, about ourselves. And that's exciting. That's what science is about. Asking profound questions, running experiments, finding answers, even if the answer is we don't know yet, because that's the beginning of discovery. So sleep now, rest your conscious mind. Simulated or not, tomorrow we'll continue the investigation, continue pushing the boundaries of knowledge, continue asking the big questions about reality, about consciousness, about existence, because that's what we do. That's what makes us human, real or simulated. We question, we wonder, we seek truth. You know, there's one more angle I want to explore with you before sleep fully takes over. It's about the practical consequences of believing we're in a simulation. How it changes not just philosophy, but actual decision making. Let me tell you about something economists and game theorists have started thinking about. If we're in a simulation, what's the optimal strategy for living? This isn't idle speculation. It's practical reasoning. If the nature of reality is different from what we thought, maybe our strategies should change too. Consider this scenario. You're in a simulation run by future historians. They're studying the 21st century, trying to understand how we navigated climate change, AI development, social upheaval. Your role in their simulation is to be an accurate representation of a 21st century person, to think and act as people actually did. If you start behaving bizarrely, trying to signal to the simulators, breaking character, you might get deleted. Reset. Replaced with a better simulation. So paradoxically, the best strategy might be to act as if you're not in a simulation. Play your role. Be authentic to your time period. Don't try to be too clever. Don't try to hack the system. Just be yourself. That's oddly reassuring. It means the simulation hypothesis doesn't require you to change anything. Living authentically is the optimal strategy regardless. But here's another scenario. What if the simulation is a test? What if the simulators are looking for certain behaviors, certain choices? Maybe they're running millions of simulations to find exceptional individuals. People who figure out they're simulated, who make certain moral choices, who show particular qualities. And those people get saved, backed up, promoted to the next level of reality. This is basically the plot of The Matrix and a dozen other science fiction stories. But it's also a serious philosophical possibility. If this is true, then being exceptional matters. Not just living normally, but striving for something more. Excellence, moral courage, insight. But how would you know what criteria the simulators are using? You wouldn't. You'd be guessing. So you're back to doing what seems right by your own standards, which is where you'd be without the simulation hypothesis anyway. Let me tell you about a concept called a causal trade. This gets really weird, but bear with me. The idea is that agents can cooperate even without direct communication, even across vast distances or different times through logical correlation. If two rational agents are in similar situations and can predict each other's reasoning, they can cooperate without ever communicating. Now apply this to simulation. You're in a simulation, you can't communicate with the simulators, but you can reason about them. You know they're rational, intelligent, they created this simulation for some purpose, and they can reason about you. They know you're intelligent. They might even predict that you'll figure out you're in a simulation. So there's a possibility of a causal cooperation. You behave in ways that benefit the simulators, even though you've never communicated, because you can predict what they want, and in return, they might benefit you, save your consciousness, give you a good afterlife, whatever. This sounds insane. But it's based on solid game theory. Rational agents can cooperate through logical correlation alone. The question is, what do the simulators want? What can you do that benefits them? Maybe they want interesting data, novel solutions to problems. So you should be creative, innovative, try things that haven't been tried. Maybe they want moral exemplars. So you should be as ethical as possible. A model citizen, maybe they want entertainment. So you should live boldly, take risks, make your life a good story. Or maybe they don't care about you at all. You're just background noise, and trying to appeal to them is pointless. We don't know. And without knowing, a causal trade is just speculation. Wishful thinking dressed up in game theory. But it's a fascinating idea that you might be in an unspoken cooperation with beings who created you, separated by layers of reality but connected through logic. Let me talk about something that really troubles me about all this. The problem of suffering. If we're in a simulation, every moment of suffering is optional. The simulators could eliminate it. They could program the simulation to have less pain, less tragedy, less cruelty, but they don't, which means either they can't or they won't. If they can't, then they're not as powerful as we thought. The simulation has taken on a life of its own. Suffering emerges from the rules they set up, and they can't or won't intervene. If they won't, then they're allowing suffering for some purpose. Research, testing, entertainment, indifference. None of these options are comforting. Either our creators are limited or they're callous. This is the problem of evil all over again, just with simulators instead of God. And it has the same non-answers. Maybe suffering builds character. Maybe free will requires the possibility of pain. Maybe it serves purposes we can't understand. But these explanations ring hollow when a child dies of cancer, when genocides happen, when natural disasters kill thousands. If you have the power to prevent that and don't, you're culpable, whether you're God or a simulator. So either the simulators are not as good as we'd hope, or they're not as powerful as we'd think, or they have reasons that justify the suffering. Or we're not in a simulation, and this whole line of reasoning is pointless. I lean toward the last option. But the problem of suffering exists regardless. Simulation or not, we live in a world with tremendous pain, and we have to deal with that. We have to reduce suffering where we can. Help those who hurt build a better world. Whether anyone's watching from a higher layer of reality or not, whether it matters to them or not, it matters to us. To the conscious beings experiencing the pain, that's enough. Let me tell you about something called the doomsday argument and how it relates to simulation. The doomsday argument says we should expect humanity to be roughly halfway through its total existence. Because most observers find themselves in the middle of their species' lifespan, not the beginning or end. If humanity lasts for 1 million years total, and you're alive now, you're probably somewhere in the middle, not in the first few thousand years. But we seem to be very early. Humans have been around for about 200,000 years, civilization for maybe 10,000. If we last another 1 million years, we're in the first few percent. That's unlikely. We're probably not that special. So the doomsday argument suggests humanity won't last much longer. We're not in the first percent. We're in the middle, which means the end is relatively soon. This is depressing. But simulation adds a twist. If most observers are in simulations, not base reality, then being early doesn't mean humanity is young. It means this simulation is set in the early period. The real humanity in base reality might have already lasted millions of years. We're just simulated copies of their early history. So the doomsday argument doesn't apply. We can be both early in human history and typical observers. Because we're in a simulation of the early period, this resolves the paradox. Simulation theory predicts we should observe ourselves to be in interesting historical periods, because those are the periods that get simulated most. Boring periods don't get simulated as much. Who wants to simulate 1,000 years of stable, peaceful, uneventful civilization? You simulate the pivotal moments, the transitions, the crises, the interesting parts, and we're living through some very interesting times. Climate change, AI revolution, social transformation, potential extinction, or potential transcendence. Of course, we're in an interesting period because interesting periods are more likely to be simulated. This is called the simulation selection effect. And it's a clever piece of reasoning, but it's also unfalsifiable. You can explain any observation with it. That's convenient, but also useless. We're in boring times? Well, that's unlikely, but possible. We're in interesting times? Exactly what simulation theory predicts. You can't lose, which means you're not really saying anything. Let me tell you something personal. Why I remain skeptical despite all these arguments. It comes down to Occam's razor, the principle that simpler explanations are more likely to be true. What's simpler? That the universe is what it appears to be, a physical system operating according to natural laws, or that it's a simulation created by beings in another universe, which is itself either base reality or another simulation. The simulation hypothesis multiplies entities. It adds layers. It requires more assumptions. You have to assume consciousness can be simulated, that civilizations reach the necessary technology, that they choose to create simulations, that we're in one of those simulations. Each assumption has some probability less than 1, multiply them together, and the total probability drops. Whereas the "this is base reality" hypothesis requires only one assumption, that reality is roughly what it seems to be. That's much simpler, much more parsimonious, and therefore, by Occam's razor, more likely. Now, simplicity doesn't guarantee truth. Reality might be complicated, but in the absence of evidence pointing toward complexity, we should prefer simplicity. And there is no evidence for simulation. None. Just philosophical arguments. Interesting ones, but not evident. No glitches. No messages from simulators. No breakdown of physical law. Nothing that would suggest we're in a computed reality rather than a natural one. So I remain unconvinced, skeptical, open to changing my mind if evidence appears, but not holding my breath. The simulation hypothesis is intellectually interesting. Fun to think about, but not believable. Not yet. Maybe not ever. And you know what? I'm okay with that. I'm comfortable not knowing. Comfortable with uncertainty. We don't have to have answers to everything. Some questions might not have answers. Some might be unanswerable in principle. The simulation question might be one of those, forever beyond our ability to resolve, a permanent mystery. And that's fine. That's part of being human. Living with mystery, with uncertainty, with questions that don't have neat answers. What matters is how we live, how we treat each other, how we pursue truth and reduce suffering and create meaning. Those things don't depend on whether we're simulated. They're important either way. So I'm going to live as if this is base reality, as if my choices matter, as if consciousness is valuable and suffering is real and meaning is something we create. Because even if I'm wrong, even if we are in a simulation, those things are still true from my perspective. And my perspective is all I have, all any of us have. We're trapped in our own subjective experience. Whether that experience is generated by neurons or by code doesn't change its reality to us. So let's make it count. Let's make our simulated or non-simulated lives meaningful, rich, full of purpose and connection and discovery. Let's be kind to each other, curious about the world, brave in the face of uncertainty. Let's pursue truth without knowing if we'll find it. Let's create beauty without knowing if anyone's watching. Let's love without guarantee of permanence. Because that's what makes life worth living, simulated or not. The courage to care despite uncertainty, the willingness to try despite doubt, the commitment to meaning in a potentially meaningless universe. That's humanity at its best. That's what we should aspire to. Whether we're in base reality or nested 17 layers deep in recursive simulations, that's the right way to live. So sleep now, my friend. Rest your mind, simulated or otherwise. Tomorrow, the questions will still be there. The mysteries will still beckon. The universe, real or rendered, will still inspire wonder. And you'll be there to experience it, to question it, to marvel at it. That's enough. That's more than enough. That's everything. Dream well. Whether those dreams are generated by biological neurons firing in REM sleep or by algorithms simulating sleep in a computed consciousness. Either way, they're your dreams, your experience, your reality, and that makes them real. Good night.